that is very uncomfortable for students. So there are now two things that we actually refer to when we say a line or a line segment.
Okay.
Okay. So a line segment is actually what we, like if you say, oh, there's a line, the line goes from A to B, that's actually a line segment. So in geometry, you have to be more specific. You have to say, oh, that this is and you actually reference it with a bar across the two letters.
Okay. Yeah,
Okay?
yeah. It's like intersecting lines and parallel lines.
That is going to happen here. So now this is where it gets different. So now I'm going to do the same thing. I'm going to draw an A and a B, but this time there's arrows on the end. So a line extends forever.
Okay.
And a line segment does not. It's fixed or finite. And the definitions here are not that important, but one of the things we have to really be careful of is using the right language.
Okay.
Okay, so the line segment extends forever. I'm sorry, the line extends forever and the line segment does not. It's that. So let me clear the screen here and just give you some more information. So if you think about one dimension is a point. Two dimensions are lines, line segments. There's also these things called rays, which we can talk about.
Right. Yeah. Like, oh wait.
Not important for the moment.
Rays.
Okay. 3 dimensions are what are called planes.
Planes.
And they're not the airplanes. They're sort of these, they extend infinitely in each direction. So imagine like you're holding up a sheet of paper and it extends forever. That's a plane.
Okay. All right.
So let's imagine for a moment that you and I, Sourish, so here's Sourish and here's Matthew, and we lived in a 2-dimensional plane, 2-dimensional space, I'll say, actually.
Okay.
And you're right here. You are right there. Okay. So there's only 2.
Oh, so that is, so it's like where my house is?
No, it's even less sophisticated than that. So in 2-dimensional space, you can either go forward or backward.
Okay.
You can either move to the right or to the left. Like imagine you're on a line, on this line here. So you like, and the virtual, this we're kind of limiting here, but maybe think of yourself, you can only move forward or you can move backwards. Okay.
Okay. Yeah.
And Matthew's over here, and he similarly can only move forward or he can move backward.
Okay.
So let's just say we come to a place right here where we're facing each other. Okay. We cannot pass one another.
All right.
And that's a little weird, but imagine you can't pass because you're literally like, there's nowhere to go. You either can go forward or backward. That's it.
Okay.
So sometimes like you can think of like a toy car, you have a toy car, one's trying to go right, one's trying to go left, and they can't. They're on a track that only goes, forward and back, forward and back, forward and back.
Yeah, it's like where I was 2 spaces, I was like farther.
Yeah. So now let's talk about 3 dimensions. This is the one that's a little bit harder. So and to draw a 3-dimensional plane, a 3D plane or space, you have to draw sort of this rectangle that's kind of off to the side. Okay. So let's say you're there and I'm there. Okay. You can go anywhere you want as long as you are on this plane. And so can I, right?
Yeah.
Okay. So we don't have that problem as before because we can go in three directions. We can go and you would say sort of up, down, left, right.
Mhm.
Right. You either are forward and backwards, left or right, but you're constantly moving. Like when you're playing video games, it's kind of like the directional pad, the D-pad, if you have one of those
Yeah.
on there. You can go any direction that you want in three, but that's in 3 dimensions.
Okay.
Okay. So it's kind of weird. So my question to you is, or my first sort of like thing I want you to think about is, do we, meaning you, me, everyone else in the world, do we live in 3 dimensions or something else?
Do we live in 3 dimensions or somewhere else?
Yes.
We're in a three-dimensional figure, so means I'm farther.
But think about the world around you.
World around me.
Yeah, think about the world you live in. The
I
world I
live
live
in
in.
North Camino del Conde.
No, no, not the street, not just the street, but just the like. Think about the world that we live in. Um, do we move up, down, left, and right? Can we do all that? Like if you get up, Sourish, if you were to get up right now, could you go? Could you jump up?
Yeah, I jump up when I go when I wake up. When I sleep,
Right,
I go down.
right, and you can go down, and then you can go left, and you can go right, and you can even go forward, right?
Hmm.
Okay, so you can actually do more than that. See how you can actually do more? You can actually go forward. You're not stuck to going. You're not like in a seat where you can only go up, down, left, and right. You actually can go forward.
Okay.
So the people in this world that talk about this stuff, they often talk about time being the fourth dimension.
Hmm.
That's sort of a science fiction thing. Do you like any science fiction movies?
Science fiction movies, yeah, like Wally.
Okay. How about Harry Potter? Any interest in that?
Oh yeah, Harry Potter. It's
Yeah.
just magic.
But
Everything's
there's
magic.
a time component to that as well. Moving through
Okay.
time and space.
Time and space. Okay.
Yes, yes. All right. So that's just kind of an introduction to geometry here. Now let's do some problems. Okay, let's talk about some things that you and I can do. So here's a line segment.
Hmm.
Okay, and I'm gonna cut it right there. So we'll go
Okay.
A,
Do I have to
B.
write this?
You do not.
Hmm.
Okay, and I'm going to tell you that AC is equal to 3 and BC is equal to 8. What is the length of AB?
The length of AB.
Yes.
Oh, 11.
How did you know that?
Because 3 is just small inches away, so 8 we have to just add to see how many hours does it take. So that's 11.
See how far it is? Yes. Okay. So now let's do it differently. Let's say I tell you that AB is 25 and AC is 13. What is BC?
What is BC?
Yes.
What is BC? BC is BC is okay, BC is 8 inches. 8.
Okay. So let's try to what does AB represent? Can you use some words to represent what is AB in this figure?
Um 25.
It's 25, but like let's just say A represented like somewhere you started and then somewhere you went to. Okay.
Uh-huh.
AC is somewhere, but it's not quite in the middle. What is AC? It's 13, right? But
Yeah.
the whole thing is 25. So how do you what number has to be here so that you when you take 13 and you add it to it, you get 25?
Okay. Yeah.
And so what is that? What is the answer to that? Um, like think of this as X. Okay, so 13 plus X has to equal 25.
It has to equal 25.
Yes.
Okay, 13 plus 12.
That's right. X is 12.
Mm-hmm.
Very good. Okay, so let me try another one here. Let's try another one here. So let's go F, G, and we'll call this H. And let's say FH, HG, FG. And let's say FH is, let's say that's unknown. Let's go with HG is 10, and the whole thing is 30. Okay, can you tell me what F to G is? F to G.
Okay. So FG right there, FG, you have to add those two.
Well, these two right here, they add up to FG. So FH
20.
plus HG equals FG. Yes. So the answer is 20, right?
Yeah.
Good. Okay. So here's how I make this more difficult. Watch this. Okay. We'll call this X, 2X, and then 30.
Yeah.
Okay. So this, this is uncomfortable. It's different now. It's letters. So we know that FH plus HG equals F to G. Part plus the other part equals the whole.
Okay.
FH is X, HG is 2X, and FG is 30.
G is 30. Okay.
So how do we solve this equation?
Okay, FG, okay. So FH plus H. Okay. So no, so FX.
The previous one represents the segments, but now we just have to solve this equation.
$28.
So what is X plus 2X? That's 3X.
Yeah. Oh, okay.
And so how do you solve for X here? What do you divide both sides by?
What do you solve both sides by?
What do you divide both sides by? Because you got 3 times X here equals 30. So how do you undo the 3 times?
How do you undo the 3 times? You just
Yes.
have to just undo the 3 times. You just have to just divide.
Divide by 3 on both sides.
Yeah.
Okay, so X equals
10.
perfect. Okay, so let's just do a quick review of solving one-step equations.
One-step equations.
Yep, so I'm going to give you I'm going to give you 4 one-step equations, and they're solved by one step. So let's go 2X equals 12. Let's go X divided by 3 equals 5. Let's go X plus 4 equals 11. And X minus 1 equals -8. Okay, could you solve these equations on your own, please?
Okay, so you just so solve one set of equations. Okay, so what you need to do is first you need to add 5 plus 3.
Which one are you solving here? Number one, number two.
Number 2.
Okay. So how do you solve number one?
You have to add.
But 2 is multiplying x.
Oh, so you have to subtract,
How do you undo multiplication?
divide.
That's right. And what are you going to divide both sides by?
2.
Okay. What is 12 divided by 2?
6.
Okay. All right. Let's go to number 2 here. What is the 3 doing to the x? Is it adding, subtracting, multiplying, or dividing?
Okay, and then for that right here, you just have to just divide both sides by 3.
It's already divided by 3. So how do you undo division?
Multiply.
Multiply by 3.
That's 15.
X is 15. Perfect. All right. Let's look at this one on the top right.
Okay. X plus 4 equals 11. All right, that right there. Okay. All right.
How do you undo addition?
Subtraction
What are you going to subtract?
of 11 minus 4.
Subtract 4 from both sides.
That is 7.
Okay, great. Last one here.
X minus 1 equals -8. So what you need to do is to add 8 and add both 1 and 8.
You're
I mean,
gonna add
1.
You're adding 1 to both sides, but it's not 8, it's -8.
Yeah, and that is -7.
It is -7. Perfect. Okay, I think we should try another grouping of these before we move on. So you're going to find that you use your algebra skills in geometry.
Algebra skills in geometry. Okay. They're going to be in geometry.
In geometry, you're going to use these algebra skills.
Okay.
Okay, so let's try another one. Let's go 4x equals -16. Let's go x divided by -2 equals 7. And let's go x plus 7 equals -4. And let's go x minus 3 equals -2. Okay.
Okay. All right, and then okay, these things right here. Okay, all right. Number 1 is -4.
Okay, very good. How about the next one?
7. Okay, and number 2. Okay. -14. -14.
Okay, very good. How about the next one, number 3?
Number 3.
Okay.
Both 7 by 7, -4 minus -7 is 11.
-11.
Yeah. And then you add both sides by 3, and then you can be able to get yourselves -1.
Perfect. Okay. That's great, Sourish. I mean, that, and so, I mean, I would love to say, like, you know, one-step equations are going to be all over the place in geometry, but they're not. But let's do a few. Let's do a few of those. So let's say I give you a line segment here, A to B, and here's C. And let's say I tell you that AC equals 3 and CB equals X and BC equals 12. Can you determine the value of X?
Okay, so for that right there, CB right there, CB is CB right there is going to be 9.
It is. Now here's how you found that. And this is important, is you wrote 3 plus X equals 12. But the reason you did that, and this is the geometry part. So here's the geometry part. AC plus CB equals AB. This is the geometry part. This is the algebra part. And then you
Yeah.
subtracted 3 from both sides and you got X equals 9. So sometimes students think, oh, I can actually just, you know, not remember all the stuff I learned last year. You're actually gonna use everything you used last year for that. Okay, let's try another one here. Let's make this a little more complicated here. Let's go A, B, and C. And let's say that AB is X plus 2 and BC is 4X minus 2 and AC equals 25.
Okay. All right, so 21X.
No. We've got to do like we did in the previous problem. AB plus BC equals AC. That's the geometry.
Okay.
So do you see that AB is X plus 2
Yeah.
and BC is 4X minus 2 and
4X
AC is
minus 2.
25?
Okay. Yeah, I see it.
So now you can combine like terms.
Okay. You combine like terms like 4X is 4X and then 2 is 4. So 4X plus negative 4, right? 1X. 1X plus 4 is 5.
5X, right?
2 plus -2.
What is 2 plus -2? What does that become?
That is going to be I think I would guess 0.
You do. So how do you solve this equation? 5X equals 25.
You just have to just multiply,
5 is multiplying X. So how do you undo the multiplication?
divide.
And you divide both sides by 5.
Mhm.
So X is
5.
5. Great. Now, one of the things though is that the problem might have said, and I didn't write it out, it might have said, what is the length of AB? Which means you have to take that value of 5 for X and you have to put it back in to the equation.
Okay. So wait, why is a 4x? It needs to be replaced, right?
Right. So it's like 5 plus 2 is AB,
Okay,
which is
okay,
7. And then 4 times 5 minus 2 is 18.
okay.
Is that okay?
All right, so okay. Yeah.
Great.
So yeah, okay. All right, maybe that is good.
So this is an example of a problem that you might see in geometry right here. And I want you to see though that there's like a geometry part, but then you always have to solve an equation.
Okay.
You're gonna
Solve an
always
equation.
you're always going to do something in geometry with lines or angles or a shape or something like that, and then you have to solve the equation.
Okay.
So those skills that you learned last year, they're gonna come in handy
Handy, well, handy for what?
for this class. I mean, you're going to use them.
Okay.
So sometimes you think, okay, I'm not going to do anything. I can forget all that. That's not the case here, because you can see in the questions we did that there's a geometric component to it.
Yeah, okay.
Okay, so I want you to think about the Earth. That's not very good. Let's try that again. What shape is the Earth, if you know?
Okay. The shape of the earth, it's like an angle. It's like the circle of it is like 3.14 for pi.
Right, but think of do you play have you ever played basketball?
I used to, but not anymore.
So the shape of the Earth is a ball, right?
I
It's
used to play basketball, but not anymore, but still I play with my friends.
cool. So that's a sphere. This is a sphere. The Earth is a sphere. Did you know that many years ago, people actually thought the Earth was flat?
Yeah, well, the earth was flat, but no, it was not. It was three-dimensional.
But they thought it was. They thought that if you got on a ship and you started sailing, that you would go off the edge.
Yeah. Well, you can't, it's not even flat because inside inside there was the crust and the core that made the earth.
Of course, but we know the Earth is spherical, right?
Yeah,
But
it's spherical.
but if you were to go outside, Sourish, and this is this is kind of this interesting. If you're just go outside, do you see an end of the Earth, or does it look flat? Like do you see the curvature of the Earth when you go outside and you look?
No, I saw that there was a wreckage and then it was not flat. There was still some more space.
Right, but we just look out and we don't see the curvature of the Earth. And that's because it's so big relative to us. Like we go outside and we look and we might see a mountain or something, but if you looked on a really flat part of the planet, you would never see the curvature of it. And that isn't that kind of interesting that
Mm,
even though it's a sphere, like at some point it's got a curve, right?
mm-hmm.
Now you flew somewhere recently. Is that true?
Yeah.
Did you look outside at the window when you were flying?
Yeah, I saw when I looked outside in the plane.
Did it look flat, or could you see the curve of the Earth?
I was not even thinking about that. I was just looking the
Yeah,
view and everything.
you'd be amazed. It still looks really flat even when you're flying. That's such a high distance. But now you've seen some of the SpaceX or the blue the people that are going up in space.
Hmm.
So if you get high enough from the Earth, that's when you can start seeing the curvature of it.
Okay. All right.
All right, well, that does take us to the end of our lesson
So
for
like
today,
the earth is like very round. It's round that I would say that
but
it's
we can't
round,
see
but
it.
not flat.
But we can't see it unless you get high enough. That's the point, is unless you get high enough, you can't see it.
Like in a spaceship.
Yes. So it's kind of
Well,
interesting.
well,
And
I
that's what
watched space movies and they went to space, and I just saw that the Earth was round, not flat.
absolutely. Yes. But you have to go up high enough to see that. Like we on Earth can't see that.
Hmm. Okay.
All right. Well, that's it for today, Sourish. That's lesson
Yeah,
number 1 of the summer. We're going to keep them short and sweet. We're gonna try and keep them interesting. You're going to do a little bit of work, but hopefully you're going to learn some things along the way. And
yeah.
so I thank you for your time, and I'll see you on Thursday.
All right. Bye,
Have a
Matthew.
great day. Bye now.